Today we're going to be covering some vectors practice questions from the A-level Edexcel specification taken from past papers and mock exam questions. So again, if you have any questions, then leave them in the comments below and I'll try to answer them as soon as I can. So the first question we're going to be doing, we have a triangle ABC. We have the vector AB is minus 3i minus 4j plus minus 5k, and the vector BC is I plus j plus 4k. So part A, we want to find the vector AC. So to get from A to C, we can go first of all from A to B and then from B to C. So the vector AC is just the sum of those two vectors. It's just the sum of the vector AB and the vector BC. So adding those two vectors up, we'll get minus 3i plus I, which is minus 2i, minus 4j plus j, which is minus 3j, and then minus 5k plus 4k is 1 minus k. So that's part A done. And now for part B, we need to show that the cosine of angle ABC, so this angle here, is equal to 9/10. So for this, we're going to use the cosine rule. Now the cosine rule states that the square of the modulus of side AC, so this side here, the length squared, is equal to the sum of the length squared of the other two sides, so almost like Pythagoras. So is equal to the length of AB squared plus the length of BC squared. But then we have to do minus twice the lengths of each of those, so the length of AB and the length of BC, and then we also times by the cosine of this opposite angle, so cosine of angle ABC. Okay, now we just need to plug in some of the numbers. So the length of AC squared is, well, AC is this vector, so the modulus squared is going to be 2 squared plus 3 squared plus 1 squared. So 4 plus 9 is 13 plus 1, just 14. So we have 14 is equal to, now the length of AB squared, so AB is again this vector here. Now the length of AB squared will just be 3 squared plus 4 squared plus 5 squared, which is 9 plus 16 plus 25, which is 50. And now BC squared, so BC is this one. So the length squared is 1 squared plus 1 squared plus 4 squared. So 1 plus 1 plus 16, which is 18. And then we take away 2 times the length of AB, so that will just be root 50 times the length of BC, that will just be root 18. And then cos angle ABC. Now just rearranging this, so bringing the cos onto the left and all the bringing the 14 over to the right, we'll end up with 2 root 50 we can write as root 25 times root 2, so that will be 5 root 2. Root 18 we can also write similarly as root 9 times root 2, so that will become 3 root 2, and then we'll have the cos A B C, and that equals 50 plus 18 minus 14, so that will be 68 minus 14, which is 54. So we're almost there. So now we can just divide through by what we have. So cosine of ABC is then equal to 54 divided by, okay, now what is all of this stuff? So we have a root 2 times root 2, which just gives 2. So we have 2 times 2, which is 4, and then times 5 times 3. So 4 times 15, which is 60. So cos of this angle is 54 over 60, and then simplifying the fraction, this becomes 9 over 10 as required. Our second question today, we have point A with position vector 2i plus 3j minus 4k. Point B with position vector 4i minus 2j plus 3k. And we have a point C with position vector ai plus 5j minus 2k, where a is a constant less than 0. D is a point such that the vector AB is equal to BD. And for part A, we'll need to find the position vector of D. Okay, so let's first find out what the vector AB is. So the vector AB is going to be the position vector of B minus the position vector of A. So that'll be 4i minus 2i. So we have the 2i, and then we have the minus 2j minus 3j. So minus 5j. And then we have the 3k minus 4k. So 3k plus 4k, which is 7k. So again, I've just done this one minus this one. So that's AB, and now let's write down what BD would be. Okay, now let's for now call the position vector for D as being D1i plus D2j plus D3k. So we have some letters to work with. So then the vector BD would be the position vector of D minus the position vector of B. So that would be D1 minus 4, lots of I. So just doing it component wise again, we have D1i here, 4i here. And again for the J, we'll get D2 plus 2j. And then for the K component, we'll have D3 minus 3. So that becomes plus D3 minus 3, lots of K. Now AB is equal to BD, so then we can set up simple equations. D1 minus 4 is 2. D2 plus 2 is equal to minus 5. And then D3 minus 3 is equal to 7. So just matching up this with this, this one with this one, and then this one with this one, all component wise. Okay, so just solving these three simple equations, we get that the position vector for D is 6i minus 7j plus 10k. Okay, so here D1 is 6, here D2 is minus 7, and then D3 is 10. Now for part B, we're given that the length of the vector is AC is 4, and we need to work out the value of the unknown constant A. So if the length of the vector AC is 4, then that means the square of the length of AC is 16. And that will just be slightly easier to work with, so we don't have to worry about square roots. Okay, so now we can write down what the vector AC is. So the vector AC is the position vector of C minus the position vector of A. So that will be AI minus 2i over here, so we'll get A minus 2 lots of I. And then we'll get 5 minus 3 lots of j, so plus 2j. And then we'll get minus 2k minus 4k, so minus 2k plus 4k, so that is just plus 2k. Okay, now the length of AC squared, so the square of the modulus of the vector, in terms of A, is then just the sum of the square of its components, so A minus 2 squared plus the 2 squared, so which is 4, and then plus another 4. And this is equal to 16. Okay, now this just becomes a matter of solving this equation. So bring in both 4's onto the right hand side. We get A minus 2 squared is equal to 8. Okay, now A minus 2 is then equal to plus or minus root 8, so plus or minus 2 root 2. So then A is equal to 2 plus or minus 2 root 2. But remember that the question says A is a constant less than 0. And clearly only one of these is less than 0, and that is the one with a negative. So A is then equal to 2 minus 2 root 2. The next question we're covering today, we have a triangle OAB, and we're given 2 points. So we're given point C is such that the vector OC is 2 times the vector OA. So the point C will lie somewhere over there. And the point M is the midpoint of AB. So the point M is somewhere there. Now we also have a straight line through C and M, and that line cuts OB at the point N. So to see what's going on, we have a straight line through C and M, and that cuts the line OB at the point N. Now the position vector of A is just lowercase a, and the position vector of B is just lowercase b. Now part A of the question, find the vector Cm in terms of A and B. So the vector Cm, okay, so to get from C to M, what we can do is we can go from C to A, and then we can go from A to M. So the vector Cm can just be written as the vector Ca plus Am. Now the vector Ca is just minus lowercase a, right? Because the position vector of C is 2 times the position vector of A. So to go from C to A, we just have to do minus A. So this is minus A. And then the position vector, the vector Am is just a half of the vector AB, but the vector AB is just B minus A. Okay, and then simplifying this becomes minus 3 halves A plus a half B. Now part B. Show that the vector ON is 2 minus 3 halves lambda lots of A plus a half lambda B, where lambda is a scalar constant. So this introduction of a scalar constant lambda hints that we need to somehow use the fact that the points C, M, and N all lie on the same straight line. Because then the vector Cn is then just a multiple of the vector Cm, simply because they lie on the same straight line. Okay, so the vector On, to get from O to N, we can go from O to C. So the vector On, we can go from O to C, so the vector OC, and then we can go from C to N, so the vector Cn. Okay, but the vector OC is just 2A, and the vector Cn we're now going to write as some multiple of the vector Cm, some scaled multiple of this vector. But we know what Cm is from part A, right? So this just then becomes 2a plus lambda times what we have here. So minus 3 halves a plus a half b. And now just collecting all the like sort of terms together, the coefficient on a will just become 2 minus 3 halves lambda. And then we also have the plus a half lambda b. Okay, now for part C, hence prove that the ratio of the length ON to NB is 2 to 1. Right, so remember that N, this point here, lies on the line OB. So that means it should have no component of the vector A, okay? Because if the vector A is pointing in basically the completely different direction, the only component that the position vector of N should have is a component of B. So in other words, this part of the position vector of N should be 0. So for part C, what we're going to do is we're just going to say, okay, 2 minus 3 halves lambda is 0. And just solving that, we'll get 4 minus 3 lambda is 0, so then lambda is equal to 4/3. And then we can substitute it back into here to end up with the fact that the vector ON is, well, a half lambda is now 2/3. So the vector ON is 2/3 B. And now it's pretty straightforward to show this ratio, because the vector ON is 2/3 B. Now so then the vector NB is, well, the position vector of me minus the position vector of N, so B minus 2/3 B, which is 1/3 B. And now clearly ON to NB is 2 to 1, because the vector ON is twice the vector NB. 2/3 B is twice 1/3 B. The fourth question we're doing today, we have 3 points given to us, and these are the position vectors. So point A has position vector 2i plus 5j minus 6k, B has position vector 3i minus 3j minus 4k, and then C has position vector 2i minus 16j plus 4k. Okay, part A of the question, just find the vector AB. So AB will be the position vector of B minus the position vector of A. So just doing the second one here minus the first one, well, we get 3i minus 2i, which is I, minus 3j minus 5j, so minus 8j, and then minus 4k minus negative 6k, which is plus 2k. Part B, show that the quadrilateral OABC is a trapezium, and we need to give reasons for our answer. Okay, so let's just, for now, plot the points O, A, B, C in just a random order. Not a random order, but a random position. So we're just going to have some quadrilateral. Now trapezium is a quadrilateral where it has exactly one pair of parallel sides. Okay, so it has exactly one pair of parallel sides. The other two sides are not parallel. So we need to show two sides of this quadrilateral which are parallel. Now we're given all the sides in vector form. So we have OC, OA, and we have AB. And now we also need to work out what CB is going to be. So CB is the position vector of B minus the position vector of C. So that will be 3i minus 2i, so I, and then minus 3j minus negative 16j, so plus 13j, and then minus 4k, so minus 8k. So CB is this vector here. Okay, and now CB is opposite OA, but clearly CB here is not a multiple of OA, which is this. Okay, so that means that if this is to be a trapezium, then we must have, okay, so these two sides are not parallel, so we must have that OC is parallel to AB, and we can check that that is the case. Well, AB is this vector here, OC is this vector here, and clearly OC is twice the vector AB, so OC is 2 times the vector AB, so OC is parallel to the vector AB. So this symbol, I'm just saying OC is parallel to AB, and then we should also say that OA is not parallel to CB. Therefore, the quadrilateral is a trapezium. Our final question today is a relatively simple one compared to the previous questions. So we are given 3 points P, Q and R that lie on a straight line, and also Q lies 1/3 of the way from P to R. So if this is the point R and this is a point P, then Q is somewhere over there. Okay, and we just need to show that the position vector of Q is this expression, 1/3 of R plus 2P. Right, so the position vector of Q we can write as, well, let's just put the origin somewhere there, doesn't really matter where, but the position vector of Q we can write as, well, we can go from O to P, okay, we can go from O to P, and then we can go from P to Q. So Q we can write as P plus, well, PQ. Now what is PQ? Well, PQ is 1/3 of PR, simply because Q is 1/3 of the way along this whole line. But the vector PR is just R minus P. Okay, and then just expanding this out and then factoring out 1/3 again, we will indeed get 1/3 R plus 2P as required. So that will wrap up today's video on vectors. I hope you did find it helpful. Now, if you do have any questions about anything we went through today, then feel free to drop them in the comments below and I'll try to answer them as soon as I can. Now, I also do offer private tutoring services, so whether you're an A-level maths student or a GCSE maths student, or you just need that extra bit of help for your SATs or 11+, and no matter if you're doing stats, pure or mechanics, feel free to reach out to me either through my website, tutor.rvmukesh.com, or drop me a comment below and I'll try to answer you as quick as I can. Other than that, if you do have any requests for future topics or past papers you want me to go through, then again, leave them in the comments below and I'll try to accommodate them for a future video. Other than that, take care and good luck. I'll see you in the next one.